Welcome to Convergence. My name is Michael Doran. I'm a California attorney. Albert Einstein said that among the most difficult problems in all of physics is the Earth's magnetic field. I'm a California attorney, and I'm arguing that among the most difficult problems in biology is the Earth's magnetic field. So today I was pretty comfortable with the 20 or so episodes that I laid out, specifically what I've been talking about. I have been musing over an additional video about the Sea of Ariel. That whole region there has been devastated with drought, particularly Afghanistan. It's all related to a saltwater body that's been killed. So you get the conductiveness of saltwater is gone from the area, and then also as the water levels dropped in the Sea of Ariel, you got death of everything, plants and fish, and that causes the ability of that body of water to decarbonate and provide rain feedbacks, just ended it. And now there's dams in Afghanistan and Pakistan. So Afghanistan, which is kind of in the whole region there, is getting a double whammy. But the reason I'm coming on today is I was preparing for maybe doing a show on that. This McKinney fire is exploding, and it has basically tornadic clouds. They're pyrocolumbus. I'm not sure how to pronounce it yet, but I'm not in the weather community, even though my father was a meteorologist, and I haven't really learned how to pronounce the name of these clouds. But I do want to talk about space weather and overall carbonation conditions that are leading to this fire activity. And also along the same line, there's a couple fires around Yosemite. One is north of Yosemite and the other is south. The one south didn't burn so ferociously, but the one north of Yosemite is burning very just in this same kind of pattern we've seen the last 4 years with these fires, and uncontrollable. I mean, it's at 50% or 45% control now, but it really was going, and then going maybe into old burn lines is the only thing that's slowing it down a little bit. And I read an article today saying why those two fires, their behaviors are different. And once again, I understand different factors do go into how fire grows, but this fire behavior that we're seeing doesn't have real precedence in my view. It has to do with precisely these electrical and biological things that are going on with clouds around the world, really. Okay, so what are we seeing with this fire in the northernmost part of California? Well, there's Hurricane Frank. It's a hurricane now, and about 2 days ago we had a near class M X-ray event. And as we go through the solar cycle and the sun has become more active, cosmic rays have started to drop. They're down to like 15% of what they were when all this started with the fires and the drought. So the cosmic rays are going down, but a couple things are additionally occurring. One, I liken it to the biological part of it. It's a feedback and a dampening. So it's like going into an ice box after you've been outside sweating and cooling yourself. It's like, woo, double whammy. And so now we're coming out of the high cosmic rays, but we also have these high X-ray events. And what hasn't happened yet is we haven't had elevated solar winds that cause tropical storms to decouple. The solar winds are about 360 kilometers per second right now. They haven't reached anything near 500 kilometers per second. So both Georgette and Frank are very healthy tropical storms in this whole region, and in particular Frank is moving up Baja and getting fairly north, and that really destroys it really weakens the Pacific High and pushes it off. And get out of here. And then Georgette is moving out into the it's moving actually in it has a southern component to its westward movement, and it's a tropical storm. But and these are really twins. They're related to each other electrostatically. There is a coronal hole, and it's expected to reach Earth on August 2 to 4. So we are going to get some elevated solar winds, which should knock those tropical storms out and change the fire behaviors a little bit. The neutron count is plus 1.1% going up. Today it's 0.7%, and at the peak of this we were at 10-11%. So it's gone way down. And the neutrons, again, are particles that create these, particularly with the Pacific High, I believe, but they create microphysics that are very favorable. So again, the solar winds are at 357.1 kilometers per second. The density is pretty good, but the solar wind isn't very fast, of 9.57. Just in the last 6 hours, there was a B3. 24 hours is a B3 as well. But about 48 hours ago, we had that was a big C, almost an M. So very significant X-ray event. And that creates a lot of particles. We saw pretty much Frank go from a tropical storm to hurricane as soon as that happened. And let me explain something. I don't think I've talked about this enough. What precisely is going on with the cloud microphysics? And so a tropical storm is going to decarbonate the ocean. It's just like opening up a beer and after you've shaken it. And CO2 comes out of it and goes into the clouds of the storm. Then helps it stack and vent. And the way it does that is water is a very powerful dielectric, and it takes energy to make a low pressure lower and a high pressure higher, and it takes energy to put charges together, positive charges or negative charges, and then when they annihilate each other just like a high pressure and a low pressure annihilates each other. But the water is in between all these two things, and that's why electrical is a complexity. The decarbonation part, not a greenhouse gas, it's about decarbonation in a surface soil going into the clouds and creating an electrical signal and how the microphysics work. Now this is what I want to talk about a little bit. I haven't talked about it much. And I was actually poking around to see if I could find the paper that got me thinking about this in the first place about 20 years ago. It was a Chinese paper of all things, and the subject had to do with cryogenics. And what they were doing is they were using a weak acid, they're putting it on a foil and connecting the foil with an anode and a cathode. And so creating a field over that foil. And then basically chilling the box that the experiment was taking place in. And what they found is with the weak acid, the crystals that froze had a asymmetry to them. They weren't round. They weren't like a snowflake. They had asymmetry. And it had to do with migrations and freezing patterns that the acid created. Well, carbon dioxide, when it's in the air, but it'll be in the air, it'll be first in the ocean, and then the winds and the low pressure, just like a soda bottle, it'll come out, and then it goes into the forming clouds in the storm. And it's the same problem, that when you start to have these static fields in the storm, the way that the ice crystals or the cirrus clouds or the droplets go from water to ice, it's asymmetrical depending upon the electrical fields. And the shape of the freezing, the way that it freezes, the manner in which it freezes, affects the rate at which the ice crystal freezes. And anytime you start getting into rate, especially in an organized way, what you're doing is you're organizing where phase change energies go into a mass of clouds. So if along the edges of the inlet, like the eye wall, you're having these different rates of freezing, you're going to start to organize the winds and the phase change energies. What happens is when a water molecule locks in and becomes ice, it gives a phase change energy to that surrounding air mass. And that energy collectively is enough to heat the air, cause it to expand, and then become lighter than the air around it, and it rises, right? And so when that occurs, you start to get into this whole idea of making a low pressure lower and a high pressure higher, right? So it's the thermodynamics of the whole thing is highly dependent, the organization of the thing, highly dependent on the electrical complexity and amount. So there's two things. There's the electrical fields that are involved, and there's the carbonation involved. And what we're seeing in the whole region right now with this McKinney fire is 2 tropical storms, tremendous amount of monsoonal activity and lightning. They're all related to the decarbonation that's occurring in a patterned way in the just off Baja. You can go to Null and you can see with your own eyes the undulations on Baja. You can see with your own eyes undulations along the Mexican coast. You can see with your own eyes along the Sierra Nevadas undulations. And then the McKinney fire is also a source of carbonation in the air. So all this stuff is taking place regionally, right? And that produces these fire behaviors that are different than even a few days ago. And so with the Oak fire, its behaviors are different than the fire, that's the northern part of the Yosemite fire. The fire behaviors are different because the clouds over the fire are different. And they're causing this vacuum to cause the fire to vent and then to spot. It's very difficult to fight that fire. It's a different fire. It's not just the conditions on the ground. Okay, so the other thing I want to talk about, as more stories are coming out about Lake Mead, maybe even becoming so low that it doesn't power the grid. I mean, and then the water rights issues are going to be unprecedented. The problem is even now, I was watching a fishing show beneath Hoover Dam. They're catching lunkers. They're catching big fish. That lake is being released even now. And as it's low, it's being released to power the dam, the power plant on the dam. And it's taking cold water from the bottom of the lake or the reservoir. So I want you to think about this for a second. So you have a mountain here, right? And you have the ocean down over here. If you have snow in the mountain, during the dry season, you're going to get flow into the nearshore ocean. In this case, the Gulf of California. If it's very dry and there's no snow in the mountains, during the dry season, the flow stops. There's no flow. And the microbial biosphere is very sensitive to this. And if you think about snowball Earths and how they would stop life in the past, the microbial response to this, and understand methane hydrates have evolved not to evolve. There's been selective pressure on them to stay the way they are, with the exception of maybe some elevated metabolism abilities that this very ancient, one of the more ancient cells has, is it can make more methane. That's just about it. But it doesn't grow legs after billions of years of evolution. It has no complexity other than making more methane. And I believe that has to do with its purpose and the selective pressure that it have been placed on it because of what it does. So you have highly sensitive methane hydrates to river changes. You have a microbial biosphere. You have carbonation levels that with surface lows are going to basically feed back heat. And what we're continuing to do with these rivers, like the Colorado, is to release during the dry season. And what does the biosphere, the nearshore biosphere see? It sees snow in the mountains. That's exactly what it would get, is snow in the mountains. It's a particular type of flow that's occurring, that's the feedback that it gives. But that's not the truth. The truth is there's no snow in the mountains. It's quite dry. And it's getting worse. And the feedbacks of heat are causing fires. And it's just not Hoover. It's just not Lake Mead. It's Oroville, Shasta, it's Powell. All these lakes, these reservoirs, they're not natural. But it's the same problem across the board, and not just across the board in California and Arizona. Actually, I think the biggest offender right now is Rio Grande de Santiago. And that's because it's a closer river to the tropics. So again, all along the tropics, there was a massive Delta D dam built in Canada. All these dams up and down the coast, whether you're talking about there's massive dams up and down the coast. There really are. And really across the world. And it hasn't been properly discussed what's going on from a mechanism standpoint. It's a dampened system, and we're screwing with the dampening. The whole world is. I mean, you can't really assess blame just on the United States. It's everywhere we're doing this. We just don't understand between how we're messing with our rivers, what the mechanism is, how fertilizers are intervening, and also part of what the carbonation is in the nearshore oceans, and then what decarbonation looks like. And that's why, while we're talking about horrific drought on the west, we're also talking about flooding in Kentucky. We get these decarbonation events in the west, and then you get a northeast flow of air, and then you get the Gulf of Gulf of Mexico with a massive phytoplankton event from all these fertilizers that are flowing down the Mississippi. And that's why we're seeing things like flooding in Kentucky. And we have to remind ourselves that this billions of years of evolution have occurred before man got involved. And so when you have nitrogen fixing normally taking place with lightning, and you have lightning causing nitrogen fixing, and then we're taking fossil fertilizers from the inactive part of the biosphere and spreading it all over and causing these phytoplankton blooms in the Gulf of Mexico, it's completely divorced from billions of years of evolution and how life has modulated or dampened the Earth's magnetic field. And this is what we're doing right now. And this is, the McKinney fire is part and parcel of feedbacks that have been dampening the Earth's magnetic field for so long. And the McKinney fire kind of reminds me of what I've heard doctors talk about cancer. My father passed away from cancer just about 10 years ago, that's why I shaved my head. But if you think about it, the research was looking at these oncogenes, these cancer genes, and seeing if they could beat cancer by focusing on a gene that might have mutated and getting rid of the problem. But as it turned out, the search to prevent cancer has come up against this wall that there's more than one gene. There's many genes that are involved in getting cancer. And likewise, when you have a dampened system like this, there's multiple ways that the Earth, over time, has multiple ways of dampening things. And so when the rivers get screwed up like they are right now, well, then there's fires. And those fires probably come from periods of time, for instance, when the moon is active and affects conductive pathways. We're not there yet. That's the Keeling-Whorf paper that came out about 20 years ago and looked at lunar cycles and climate. We're halfway through that cycle. When that cycle is in a certain place, at the maximum part, there's evidence of fires in California. But we're not there. But there's fires. There's mega fires going on. And it's because of these defects and feedback loops that we're creating with dams, fossil fertilizers, other land uses. You go about an hour and a half from here to the redwood forest, and it's a majestic place. I highly recommend any of you who ever come to California to visit the redwood forest. It's breathtaking. And there's redwoods all around here. But particularly along the coast, it's awe-inspiring. But there's only 5% of the forest left. We took it out to build San Francisco and so forth. Only 5%. There's multiple levels to this in terms of how the Earth dampens the Earth's magnetic field. And humans have become so much bigger than life itself, and we don't even know it. That's the crazy thing. So we don't even understand what we're doing, and wanting to plant 1 billion trees or whatever the movement isn't necessarily going to solve it. It's not about CO2 as a greenhouse gas. That's part of it. It's taking chemicals from outside of the active biosphere and putting taking it from the inactive part of the biosphere and injecting into the active part of the biosphere. It has a signal noise, meaning, yeah, it does affect what's going on. But the mechanisms that we're talking about are much more complex and are about electrical conditions that dampen the Earth's magnetic field. Again, if the Earth's magnetic field is too strong, it just attracts too much gases and so forth from space. If you think about a planet like Jupiter, it's a gas ball. Well, where does that come from? That comes from space. And if the Earth's magnetic field is too strong, it's going to pick up these gases, and it's going to create non-living situations, which again goes back to why methanogens don't change. Their purpose is part of this dampening. It's so strong that if it's not there, then the Earth starts to become too much of a gas ball, and it just puts selective pressure on that life form from changing in any way. And the converse is true, is if the Earth's magnetic field gets too weak, the atmosphere starts to strip away, and it goes out of balance the other way. You have Mars, a dead planet. So we've gotten, as human beings, so abundant, and so many of us, and so powerful with our technologies that we're starting to interfere with these processes that are billions of years old. And as a consequence, it's to our own detriment. And so we're seeing, right now, what we're seeing is a symptom of our problems is a fire like the one in McKinney. Okay, I've talked myself out. I wasn't even planning on doing an episode today. Happy Saturday. Hope your rest of your weekend is good. If you like this channel, please subscribe. Please like this video if you like it, and have a good one.